using Spring Boot 3.0. I will try to read their release notes first. What I know is there are native image builds I am interested in, because it was the topic that I was always not happy, because the image size of the JDK, because of the image size of JDK. And also I will check this OpenTelemetry integration, because same reason, there was a couple of libraries like Sloat and some other third parties in order to set up some kind of distributed tracing stuff, but we will see right now. I'm also happy about Java 17 long-term support. And I will be using most probably Spring CLI or some built-in feature of IntelliJ IDE. Let's start then. Maybe full screen better. Okay. So here, let's double check their Spring release notes. So Spring Boot 3.0 goes GA. Yes, in Spring Boot 3.0, there is Spring Framework 6. Yes, Java 17 baseline. We will be checking support for generating native images with GraalVM, improved observability with micrometer and micrometer tracing. I've never used Jakarta EE, so most probably I will not experiment this one. Maybe we can start a quick project here. Okay, the pop-ups, etc., they are already visible. So if you want to use, there is a project which is called Spring Initializer. You can go to that Spring Initializer in order to create a project, Spring Initializer, this one. So the first option is you can go to here, select your dependencies, provide some kind, you can add your dependencies here. Package name, which build tool you will use. Will it be Maven, Gradle? Which language do you want to use? Groovy, Kotlin, Java. Also, you see they already have 3.0.0 of Spring Boot. And the remainings are metadata of your project. And what kind of artifact do you need? jar, var, and your Java version, of course. Apart from that, you can also use command line option, right? It is Spring. You can also use this one. I used this widely, but a couple of months ago, I just saw there was a built-in integration in Java IDE. Maybe we can use that one also, right? Here, when you type Spring, you can see Spring Initializer. Let's do it Spring 3 playground. Not Spring Boot 3 playground. Folder. Okay, and I will use Java. I'm not using Kotlin or Groovy yet. I have used Groovy a long time ago. It was a cool language, but I never used Kotlin. Type, yeah, let's use Gradle. I will do this org.in, my name, artifacts, that's fine, package name, fine. JDK, it can be OpenJDK 18, but let's not change our context, and I will use Java is 17, right? And packaging, as always, jar. Oh, you see, Spring Boot 3.0 is already there. Let's not use snapshot because I don't think there will be some kind of cool feature in 3.0.1, but we can use 3.0.0 still. And developer tools, you see GraalVM native support. So here in the dependencies, you can check any kind of your favorite tools here. For example, since we are using Java 17 here, there will be lots of usage of Java records. Maybe we can just ignore Lombok for now. For web, I want to use Spring Web. Maybe just add a couple of, you see observability. In observability, what we have, distributed tracing. Okay, I will add that parameter later. But where are your data? Spring SQL. Okay, Spring Data JPA, this one. So let's start with those and let's see what happens. Right. Okay, meanwhile, maybe we can check because it will download the pre-built shared libraries. And meanwhile, we can check these documentations. So especially, I just wanted to focus on this one. Oh, any way to close this sidebar? Oh. No, no. What is you ever develop and you run it, right? You need to have a compile tool for that, JDK, which is JDK, Java Development Toolkit. And also you need to have this JRE, Java Runtime Environment. That means, let's say that you are building a cloud native application and if you want to run it, then you need to build your Docker image first, and you need to run it in a container. And this container, this Docker file, should be derived from some kind of Java runtime environment compatible Docker image, right? That means at the end, you need to have Java runtime environment. But think about other languages like Go, for example. In Go, you can build your project in order to generate an executable binary. So this binary means in Docker file, you can use very, very tiny Docker image as a base, for example, Scratch. Scratch means zero-based, zero-sized Docker image. And then, as an entry point, you can provide your executable binary. And in Go applications, if you use some kind of compressing parameters while building your Go application, you can have something like 3 megabyte sized Docker images. And since Scratch Docker file, Docker image does not have any kind of size, then you will end up with something like 3 megabyte of cooler. But when it comes to Java, I don't know the latest size, but it was around 80 megabyte maybe at least. But here, my expectation is when you say GraalVM native image support, they are generating this executable like in Go, or maybe you have ever done it in C++, maybe C, same rotation. So what is the key differences, static analysis of it? Oh, so there was something like the fact that GraalVM native images are produced ahead of time means that there are some key differences between native and JVM-based applications. So think about the Spring application. In Spring application, the very popular strategy under the hood, what is it? It is dependency injection, inversion of control. And when you have a look at the, for example, if you have a Spring application, if you try to debug it, you will see lots of proxies while debugging your applications. For example, if you have a product service, maybe you will see something like product service proxy. And also, there is an auto-wire operation in Spring, right? But this kind of magics are done by mostly using reflection. And so you are using lots of annotations, and those annotations are maybe just analyzed during the runtime. While your application is running, and Spring decides that what to do next based on your annotations, maybe configurations. So here in native image notation, there is something called build time. What was it? Where are you? Yes, understanding Spring ahead of time processing. So here, the beans definition in your application cannot change at the runtime, meaning the Spring profile annotation and profile specific configuration is not supported. There are some kind of limitations. So here, this topic just helps you about before compiling, before running your application, this feature just understand what to do with your code base. It just does some kind of refactoring, and it just produces some kind of final version of your application, right? That means if there are lots of unused libraries or something like that, they will be just ignored, and you will have very, very tiny source code at the end. So there is source code generation. So if we take source code generation, Spring applications are composed of Spring beans. Yeah, you know beans. Internally, Spring Framework uses two distinct concepts to manage beans. There are bean instances, which are the actual instances that have been created and can be injected into other beans. There are also bean definitions, which are used to define attributes of a bean and how its instance should be created, right? So here, for example, this is the well-known usage, right? There is a configuration class and there can be a bean inside it. Here, my bean, it is just creating an instance of my bean class. The bean definition is created by parsing the configuration class and finding the bean method. In the above example, we are defining a bean definition for a singleton bean named. The default scope in Spring is singleton for the beans. There are lots of other scopes like user session, or I can remember the other names, but there are 4 or 5 sessions scopes in Spring Bean. For example, when you define this one, you guarantee that there will be only one instance in your application during runtime, right? But there is another type, singleton. Since the scope is singleton by default, you will have only one instance. But there are other type of beans, something like you just want to generate different kind of sessions per user request, right? I make a request application. This is my scope, and user B just makes another request. He has a dedicated scope for him. That's why this kind of beans cannot be singleton, right? They need to be completely isolated. One sec, I will be back. Sorry for the interruption. Let's continue with our description. Okay. There are some other internals here about how it is doing some kind of optimization, let's say that. And maybe we can just quickly switch to the generation part. Okay, here they are saying that we need an example application that we can use to create our native image for our purpose. The simple Hello World web application that's covered in the Getting Started section of this office. Okay, there's a controller. This is also an application. There's a request mapping, fine, and we are running the application, right? And is there any kind of task or some other stuff? Okay, we can check it. Let's just write an application, very simple one here. Java. This is the background. We can also write an embedded action here. Okay. So I just converted this one into a REST controller. Now I can do a get mapping and maybe ping and public string. Okay, let's run this application. Okay, since we added Spring Data JPA, you need to provide a data source URL, right? Let me just remove it for now. Here, let's just remove it and run again. Do we have any? Oh, okay. Okay, now it is running. We can use internal feature of the IDE. Let's do a get request to here, ping, and POC. So this application is running. I mean, there is no problem about running the application. And I expect to see something like here in Gradle tasks, there is boot run. Okay. In build, you see there is AOT classes. What else? There is NativeCompile, right? Maybe we can reuse these tasks. Let's continue with this native image. Okay, this one, build image. Maven, there's a Maven stuff for that. Using Gradle, it is Gradle boot build image. Let's do this. Terminal Gradle boot build image. So we already saw ahead of time compiler related stuff, AOT classes, some other stuff. Is boot build image, it just executes these tasks in a specific order. native. I think it is also built Docker image. Maybe that's why it is taking so much time. What I see is it is using library Spring Boot 3. Okay, it is building a Docker image. That's why. But is there any way to just only compile the application and that's it? There's a native compile using Gradle. Native compile, yeah. I expect to see some kind of executable if we say native compile. Maybe I can just okay, I will stop this one. Gradle native compile. Oops. Native generated. Okay, when you say native compile, build native compile. Build native. Oh, it is failed. Okay, okay. Let me do the same stuff in the terminal. See. Okay, there is no graalvm, of course. Okay. I assume there is a brew search. Yeah. Let's try our chance. Brew install. No. Okay. Really? Here echoes. Support star. Okay. They're the same thing. And this first prop. I need mem. Really? No Gradle? Normally, you should use this one as a test implementation, not implementation. What about this? Okay. Now we have Gravian. There is something related to privacy. Oh, damn it. to just this. Why Java 11? Okay, let's wait for it. This is done. Application properties. This is also done. Yeah, like does this application again can be a problem. Okay, and here we can true. Password. Now, but of course, with okay, Graalvm seems downloaded. Let me extract it. Okay, now I downloaded Graalvm. Where are installation? Okay, we just unzip. Move the downloaded package to its proper location. Library Java virtual machine. Check it first. So here we already have something here, but I don't know if it is correct or not. Java 17.230. And basically we already downloaded it. Okay, remove. Let's remove this one. Stop. And then copy it here. What was it? It was under downloads. Okay, now we have the proper version. Okay, this is damaged. Now again, make M1. Maybe there is no M1 support, right? So it seems there's a special documentation for M1. To what we have. Okay, we have a greater version. And okay, let's do this. Copy. Okay, just copy that. Okay, install the stage. Also use this. Okay. The the version should be, what was the version? This one. So there's a problem there, but couldn't get it. Sudomo 12 Java version. Okay, graalvm CE Java 17. Everything is here. Graal. Okay. Okay. Yeah, here graalvm is here. Okay. Hold on. There can be multiple JTKs. The next step is to configure the runtime. Okay. Yep. Okay. Come on. That's it. This was the error, by the way. If you are using Catalina or later version, which is I am using a very up-to-date version of Mac Monterey, you need to execute this command. So that was the root cause. Anyway, let's execute our command again. JTab bring Gradle NativeCompile. Okay. Now it will build just executable. So welcome everybody. One. So let me take a tea and I'll be back. Back. Okay. Let's check our compilation folder, native. There should be something under this folder. Documentation. Under NativeCompile folder, there should be an executable. Okay, you see? Oh, okay, they are using same notation. Performing analysis, classes reachable, fields reachable, methods reachable. For reflection, data access. You know, this reflection part, it is already something that is used widely in a Spring project. Do you have any kind of example, what kind of, for example, for which feature Java using or Spring using reflection? Do you have any kind of example for that? So this is huge. Container file, initializing beans. Yep. What else? So why we need just reflection? Because by using normal notation, you cannot access a field, for example. There's a private field. You cannot access it by default if you are inside the other package or something like that. Then you need a reflection to access there, right? For example, Spring uses auto-wired. So there's a private field. There's an annotation at auto-wired. But somehow Spring is able to access that field. So it is using reflection to access there. Reflection is some kind of parsing the code base and then try to access there by using some kind of magic. Okay, you see the native image written. By the way, the compilation takes too much time. I don't think it is related to my computer because I have enough memory for that. But you see, they just provide some kind of memory summary. And there's JDK proxy. We already mentioned about security Java util invoke crypto core. Okay, let's see. Here under NativeCompile, now we have a binary, right? Let's in the terminal just go to that one, NativeCompile, and just see the sizes here, byte, kilobyte, still 136 megabyte, right? Let's see if it works or not. Yep, same application. And you see how fast it is? It is fast because in the traditional Spring Boot application, Spring decides to do something while it is starting. But here, ahead of time compiler. It does some kind of analysis and it generates another set of code base. That's why the application starts very fast here. Okay. So maybe what about this Gradle boot build image? Oh, because we are not in the root folder. Okay. So you have a code base, you have native image build by default, and when you say Gradle boot build image, it will just generate a Docker image for you. Let's see what is the size of this Docker image. Okay, we are already run the application. They mentioned about OpenTelemetry, right? OpenTelemetry and micrometer tracing. What they did, let's see. So maybe just a brief explanation, able to observable. For example, if we talk in a Spring context, you need to somehow provide, let's say that you are building a microservices application and you have lots of services. In order to fulfill an operation, something like place order, this request need a couple of payment service, this kind of things. So initially, it generates a trace ID. Yeah, this trace ID is propagated from context. The telemetry data, trace ID data, just ships over the sources. This is not the only thing. So traces is the number one item. There is also metrics. What are they? They are something like useful applications, for example, request latency, response latency, this kind of thing. You can also ship logs. So trace, metrics, and logs. These three items just consists observability stuff. When you open your observability dashboard, for example, you can see which service performs how. If you see some kind of peak, for example, in the request latency, you can also take a look what happened there by using the application's log. It is something like that. As you can see, it is created. There is a context here. It is shipped here, started, and stopped. So how it happens in Spring? In Spring, if you are using REST template for service-to-service communication, you are using REST template bean, of course. Spring by default just put some kind of REST template interceptor there if you are using this observation stuff. For example, in the exam in here, there's an observation register here. It creates it. There is a specific handler. You see, they put key value pairs. You can say that they are just metrics. And at the end, they say observe, and there is a log. So there is okay. What about this image build? It is still building. Okay. So there are a couple of parameters here. What are they? There is server port, application port, server port, application name. When it comes to tracing, they are just normally this OpenTelemetry system. They use some kind of sampling mechanism. They are not analyzing all the traces by default, but you can just set this probability number. Here, when you say 1.0, that means all the traces will be shipped to the collector endpoint. And here, yeah, this is what that means. And there is a Prometheus coming from the actuator, right? Percentile histogram is true. For example, we work with unit histogram buckets. Okay, there is the previous section of this one. Loki, this about metric system in Grafana stack. They also have a logback configuration to include trace ID inside any log. The REST controller here, let's see what happens. There is a configuration, user service. Okay, most probably whenever you call, but there is a user service. Whenever you call username method, this name, let's say that metric key, there's some kind of another values, they will be shipped to the collector, whatever it is. Any dashboard or something like you see, there's another example, REST template. In REST template, there is not a specific stuff, but in client code, is there anything special? Okay, you see, in order to use this tracing, you shouldn't do a new REST template. Instead, you need to use REST template builder and builder build. So it's something like there's a REST template instance in the pool that Spring already configured. You need to use that existing one. Why? The main reason is when you make a request from service to another one, first service just generates some kind of tracing data. When you use, for example, post method, then that tracing of OpenTelemetry information will be shipped to second service. If you are using this REST template builder, there is already an interceptor inside this REST template builder that just gets the specific headers, something like trace ID, span ID. But if you do new REST template, then it's gone. So you have totally new REST template instance that does not have any kind of OpenTelemetry information. Okay, there is Prometheus, there is Grafana. When you run them, okay, Loki is the log tool of Grafana stack. Here you see there's client, server. This is the trace of the entire flow. So there is trace, right? The first item. And also you can see the metrics here. For example, 24 millisecond, 48 millisecond, this kind of things. You can see the distribution of latencies. And also there is logs. So you can say that this is my observability dashboard. Come on. I will create something like, I don't know, tens of images by using other languages, but here it is a bit huge. Maybe I need to analyze what is the main advantage of using this one, right? Because the Docker build image part is taking too much time. So in a proper CI environment, I should get my feedback as soon as possible, right? But here, build image takes too much time. Okay, I see some kind of couldn't resolve. Maybe it is related to internet, but I don't think so. Okay, there was a good usage about this, what was it? Declarative clients, right? Client interfaces. Okay, let check that one also. String code tree client interfaces. Declarative HTTP clients. This one. So what we do is, let's say that you have an interface. I mean, let's say that you have a Java class user client. This is the client you use to connect to user service, but there is no real implementation. This is just an interface. But how? Let's put method here, for example, string, or do something like boolean is exist and major product ID, or no, user ID. Okay, so here this is just a function, but if I put here get exchange and just put the URL, the context path of the service, but this is a listing operation. Most probably it is something like this. Let's say that ID here and ID. This should be mapped to this one. So here, let me do this. This is a REST controller. I will do private user client, user client, user client. User client dot exist 5. Let's return boolean. Okay. Okay. No worries. Auto-wired. Okay. Since they are using Flux, they subscribe to this data. But since we use the direct method, so if I run this application, oh, it is still building. Come on. So I wouldn't use such a build operation, by the way. It takes too much time. Oh, you see, consider a bin type. Okay, why it is just public interface? Oh, I think this configuration is needed. Yeah, yeah. Let me this one. paste it here. Okay. Okay, web client is coming from this web flux. Let's add it. Gosh. Oh, it is vulnerable. What is this URL anyway? And we may need to use flux. Okay, flux is here. Line, but oh, factor. Here it should be subscript. One sec, I will be back. Back. So So the main take is you can define interfaces and they can act like a real implementation. So do you remember some kind of equivalent library for that? There was a Think line. It was doing same thing, so they just replaced it with declarative HTTP. But I couldn't know there should be a web configuration for this. I assumed that it is building something, but we need to use this web config to make it work, especially this one, user client. Otherwise, it says there is no such a bin definition. Okay. Oh, I need to close. So Docker image build is just a mess. I wouldn't suggest that one. So about Spring Boot 3.0, my main feeling is native build image is fine. But as you see, I am using M1 and it was problematic on the first installation, and it was hard to understand what's going on there. So that very tiny command did the trick. I think they should be more visible on that. Even I have used Brew install. It is not working. Maybe in the Brew install, they should execute this command directly. But overall, this being able to run Spring Boot application through the executable. When it says native, I think it is more than reflection. It's not just a reflection because this AOT stuff, ahead of time stuff, I think that is the their main implementation. So whatever Spring decides on the runtime or application start, they do that in advance. It's not an easy stuff, but they are using huge stuff, lots of things, including reflection. When they say native, I think it is native to your operating system, right? Let's say that you are using Windows and you are generating Windows compatible executable. So there is no Java, there is no something else. There is only an artifact that can be executed inside your computer. That's why they are saying native. That's my understanding. So being able to execute this native stuff, that's fine. Building Docker image, I think it seems a total mess. At least in my computer, it took too much time. Declarative HTTP interfaces, they are cool, but to be forced to implement an additional web config, I think it is not a good stuff because in Think line, for example, I add only dependency and that's it. So with a couple of annotations, I can do same stuff what you see in declarative HTTP interface. Java 17 support, there is no real take on Spring side, but at least if you have any kind of problem related to Java 17, for example, you are using record and there is a problem, then you can ping Spring team saying that, okay, there is a problem in Java 17. In the previous versions, the stable version was Java 11. And if you report something about Java 17, most probably they will say that, okay, we don't support it. But here in Spring Boot 3.0 is the LTS version, long-term support. I haven't tried micrometer tracing yet, but what they did in the observability domain, I think it is very cool because they were using something custom, Spring Cloud Sleuth. But when the OpenTelemetry came into place, maybe you know the history about OpenTelemetry. There was distributed tracing, open consensus, different kind of RFCs that you can see some descriptions about distributed tracing, metrics, this kind of thing. They concluded that instead of having multiple foundations, let's combine them and have everything in one place. And that is called OpenTelemetry. And Spring also adapted itself to OpenTelemetry, which is very good thing. I think it is due to Java's nature. Whatever you implement, it is too verbose. In order to do something, you need to do two or three line something. You just saw this code pieces about observability. You need to do a couple of things to initialize something. But still, having the same sense about OpenTelemetry is a good stuff. I'm interested what they put inside this 3.0.1 version. Okay. 3.0.1 is not, or maybe there's a milestone. This release candidate of 3.0. It's not 3.0. Maybe GitHub or milestone. Yes. They already finished it. Seems there is a problem with boot build image. See? Okay. Due to nature of this is a patch release and we cannot see just an enhancement, new feature, but there are lots of bugs they just fixed. Any benchmark? Okay, there is no benchmark. If you are using boot version 2, you need to do an iterative upgrade. For example, you cannot upgrade from 2.3 to 3.0. You need to upgrade from 2.3 to 2.4, then 2.5, 2.6, whatever it is. Otherwise, you can get some kind of huge errors. They do not provide a guarantee if you jump versions. And also, whenever you want to upgrade some version, you can check Spring repository. They mostly provide migration script to do that. It was something like Spring Boot. Yeah. So they had some kind of migration script. I couldn't remember the name, but I saw it in their release notes. Change that, for example, they rename some class names, etc. They change the signature of methods. In order to help you, you have lots of modules, and that migration script can help you to understand that. Anyways, so most probably my overall score on using Spring Boot 3.0 would be something like 6 out of 10. I cannot say that I am super happy about that, especially being able to generate executable. That's totally fine. But I expect to see some Docker image size less than 160 megabyte. This is not a good thing, I believe. Maybe they can decrease it a bit more. I know that it's totally dependent to GraalVM, but maybe they can improve it. Yeah. Okay. That was it. And okay. Thank you for watching. And maybe the upcoming sessions can just check another component of Spring Boot or some other language. We can take a look. You know, in Go also there is new version coming up, 1.20, and we can take a look at features of what is new, what are the new version of Go. Okay, thank you, and see you next time. Bye.